Alright, so I will be going forward with Todd's slides since I don't have anything special prepared. So next thing that Todd was going to go over was routing and Restful. So routing, we can do it manually like he showed us last Tuesday, which is rather tedious with the switch and case. It's just a pain, and then it doesn't really help if you've got any kind of special needs with your special things you want to add on to your paths and such. So there's the serve mux, which is part of the HTTP library, which will deal with routing different URLs to different functions automatically. So here's how you use it. You create a serve mux, HTTP serve mux, and you tell it handle with a URL with your URLs. You pass it your normal handlers. So dogs or dog handler just got to serve HTTP just like you normally would. So then you can pass the mux as the overall handler for listen and serve, and that will deal with going to the appropriate subdirectories. Now, serve mux is nice because it will match to the closest URL possible. So like right here, we're just going to /dog/ which is what this is. Then over here, we're going to /dog/ and everything /else, and it still goes to the dog function. Because this first part here matches. So that's why to get like a generic catch-all case, you can just put just like a plain /, and that will catch everything that's not caught by something a bit specific, like the cat. Dog's handler, mux's handler, listen and serve takes handler. You can mention the dog thing directly, which means you won't ever get to cat. Oops. Alright, so, alright, exercise to make a web server that just shows a picture of a cat or a picture of a dog using serve mux. There's the answer. But this is basically how a real web server will look like. Is something very similar to this. So we would use templates instead of just directly putting HTML in. But other than that, this is pretty much how an actual web server would look like. So besides HTTP serve mux, there are other routers. Serve mux is slow. It's painfully slow. So there are lots of other routers. Gorilla's got a bunch of different things related to stuff. So if you're already using Gorilla, it's going to use its mux. Julian Schmidt's HTTP router, however, is one of the best. It's extremely fast, and it's pretty low on memory usage, too. And Julian Schmidt actually made a little routing benchmark where he compares the top 20 routers, including his own, and the serve mux. If you want to look at that, you can find lots of numbers. Julian Schmidt's HP router is currently pretty much the best. It may not be the first in any particular category, but it's second or third in every category. So there may be something that can beat it in like memory usage, but that one's extremely slow. So overall, HP router ends up being the best. So moving on to Restful, which is kind of why you need good routing. It's to get a RESTful web service. So a RESTful web service would function something like this, where part of the URL affects what you're actually putting on the web page or what it's doing. So like right here, you get /cat/ and it goes to the cat handler here, and it checks the path and splits it on slashes. And if there's a third item in there, it grabs it and puts it into the response. Same thing for the dog. So if you have /dog/Toby, it'll grab that Toby and put it into the URL, or Roger put it into the URL, or into the HTML coming back. So this is RESTful. You can do whatever you want, so might as well do something fancy with it. Maybe pictures. Okay. So, but you can overdo it. So like right here, if you've got a URL for an item and you do a put on it, it'll update it. You delete it, it'll go destroy. It'll destroy it. If you get it, it'll show it. You go to new item URL and you get it, it will new it. Edit item URL getting it, will edit it. Items URL getting it, will index it, or create it. It's getting too complicated. You can't keep track of it. So here's the RESTful hint for 403. If you have to ship an SDK for your RESTful API, it's not a RESTful API. So don't follow GitHub's example. They've got like something like 200 something possible URL combos to connect to. They've got 30 pages of documentation on it. So a bunch of Stack Overflow responses of what RESTful is. But basically this, where you can take part of the, you've got basically part of the URL here, the variable, essentially. The third part of the URL is a variable that goes directly into HTML. Yeah.
Why do they call it RESTful?
I'm not actually sure. I'm pretty sure it's an acronym of some sort. But you can look it up.
Routing.
Routing. That sounds representational state transfer.
Oh, wonderful. It wasn't routing.
Yeah, I would have thought, but
RE.
yeah, okay. So, but basically, part of the URL is basically variable or a way to send data in. So, oh, and it looks like Todd decided to jump back to Julian Schmidt HTTP router, which has got some interesting features. So, whereas the HTTP route, servmux, will go for best matching, so you can do just a plain slash, it'll connect to everything. Julian Schmidt, instead, slash just means slash. You can't put anything extra onto it. And you can also do hello, and stick a colon before a variable, and that will be a variable. That will be a variable that can be looked up in the function. It'll grab it automatically, so it can be grabbed. So you don't have to go parsing the path yourself. It'll deal with that for you. So Julian Schmidt's router is you create a new router, and then you can set its routes with .get, with URL and handlers, and then it goes as your overall handler. So besides get, you can also do delete, head, options, patch, post, put, basically every HTTP method ever. You're probably not going to need more than get, put, post, and delete. But there are a couple others which it makes available in case you decide you need them. All right, the handle func. Handle func is for HTTP router, where that's okay. Yeah, look at this. Look at this. Look at this. Okay. So like right here, this is a pain. You have to create a whole type that's not being really used, just so you can attach a function to it so it fulfills the interface. So the handle func basically says that if you use handle func instead of handle with the servmux, you can just pass in any function that takes in a response writer and a pointer to a request and returns nothing. So like right here, he's just using a couple anonymous functions, and this will work. So, or you don't have to make it anonymous, you can put it out here, which is what it's more usually doing, and put the name in, and it'll work. This way you don't have to create a whole type. Here's the entire code to make handle func work. A type handle func is just a function, and it's a serve HTTP just calls that function that it is. And that's all. Yeah, the handle func function takes in a handler function func, just like a handle. The handle function takes in a handler. Oh, and the default servmux, since it's part of the system, you don't actually have to create one separately. You can just say HTTP handle func or HTTP handle, and just pass a nil for listen serve, and use the default servmux, which is a global object. So if you're running more than one server in the same program for some random reason, you'd have to do it manually. But if you're just running one server in it, which you're probably going to be doing, you can just do it this way for even less line of code. So when you're building a web app in Go, you're going to have a bunch of routes for different web pages or something. For each of those routes, you'll have a handler function or a handler, which a servmux or HTTP router or something will separate for you. So yeah, what's in the serve takes an address and a handler. Handler is taken into response writer and request. Servmux does the routing. Fancy stuff. Restful. More review.
Can I ask a stupid question? What's the difference between a handler and a handler?
So the handler is like this, where you have a whole type and just fulfills the interface by having a serve HTTP method, whereas a handle func would be more like this, where you just have the function by itself, and then you call handle func instead of handle. So let's code to write, especially if you don't need that the type. Like that. Got a whole extra hint there floating around with the handle that's used. No, you can put whatever you want. You can make a struct for a handle or something if you put extra information that's saved between connections or something, but not usually needed. Restful. That's it for routing and Restful. So a short section. But hopefully serving files. Yes, I remember going over this. It'll be entertaining. I'm not going to bother splitting the video. It's a pain. Alright. So yeah, serving files. So easy way is IO copy. A connection with a writer, a file, an open file is a reader. You can use IO copy, which takes a writer and a reader, and will do so. So here is an image served from Wikipedia. It's got image source equals a Wikipedia thing. So if you want to do it yourself, like this, it gives you nothing. So to show that, you put, Todd puts in a generic handler that handles everything, and all it does is print out the URL. So dog will go to its normal thing, but then anything that's unrecognized will go here, which just prints it out. So you can see the toby.jpg is not being handled. You've got to deal with that yourself. So you make a Toby JPEG route, which goes here. It'll just open the actual file on the server's hard drive, defer its close, and then copy it and file to the response writer. And now it works. So there's a bunch of stuff, however, this misses. Like you should set the content tag. Otherwise, I mean, not most web browsers will be able to figure out that this is a picture, but there are the random people who are using some obscure web browser that no one's ever heard of before that doesn't have that ability. You should be using e-tags, which are useful for various things. I'm not entirely sure what all it's useful for. And then there are other stuff. There are easier ways to do it. But first, we'll look at HTTP error right here. So HTTP error takes in a response writer, a plain text string for what the error message is going to be, and an HTTP code like 404. So like right here, if it couldn't open the file for whatever reason, it puts the response into there, says file not found, gives a 404. So 404 error. And then immediately returns out of the function, so it sends the connection like it normally does. So this is how most error handling in a server is going to be. In a plain program, you're usually going to use like panic or log fatal line or something. Those will immediately exit the program, which you don't want to do with your server. You don't want your server just shutting down because there was some problem. You want to send a message back to the client so they know that something's wrong. You probably want to log a message for an admin to look at later so they can see that something went wrong. And then you move on. You keep going. So actual error handlers look exactly like this, except with a line for logging a message for the admin with details. So there's an easier way than IO copy, which is HTTP serve content. So after you open the file, you use the stat method on the file to get the file info. And then you can use serve content. Serve content takes in response, the request, the name of the file, which the file's got a name method to get, when the file was last modified, which the file info from the stat method will give you that, and then the actual file reader itself. So there's what I said, pointed out. So it doesn't want just like a reader, though. It wants a read seeker, which OS files implement. So that's fine. Read seeker basically means you can read from it, and you can jump around in where in the file you're looking at the moment. So, which files have read and seek. So that's fine. File info has mod time, which is the time you need. So yeah, this will deal with putting up the content type and dealing with e-tags and all that other fancy, tricky HTTP-specific stuff for sending files. But there's an easier way. HTTP serve file takes in the response writer, the request, and a file name off the server. So our dogpig function here can just be HTTP serve file, response request, toby.jpg. It'll open the file, it'll read it, and do everything appropriately. Much, much smaller. But there's an even easier way. HTTP file server. With HTTP file server, you don't even have to make a handler function yourself. HTTP file server just takes in a file system, which http.dir will give you, and that's a handler by itself. You don't have to make your own function anymore. So this is basically saying, if I don't know what the path is, go to the current directory and send it directly back. Which means you can look at that dog, or you can look at your code, which is probably not the best thing you want. Which is why you increase the size to this massive monstrosity of a line, which is still just one line, though. So this series of things is kind of hard to explain. Todd's got his explanation, which you can look at and read yourself. I'll kind of try to do my own explanation here on the fly, though. So basically, in this example, he's got the image sources, the web servers, resources / toby.jpg URL. So anything he puts here, anything that goes to resources goes to this handler, which is big, massive handler. The image, however, is in the server's assets / toby.jpg folder. So the file server needs to look at stuff that's in the assets folder. So at hp.dir, this is where on the server's hard drive the stuff's going to be. So assets folder, file server. But the URL is resources / toby, which is not what we want. So HTTP strip prefix takes in the first part of a URL and a handler. And basically it'll just pass on everything to its subhandler, stripping this part of the URL out in the beginning. So now the request comes in for resources toby.jpg. Strip prefix will strip off the resources part, so it's now just toby.jpg, which the file server here can handle and deal with. You don't need to add assets on because this file server is already looking in the assets folder. And so the URL doesn't need to have assets on it. Yeah?
So that's handling like the secondary call to fetch the image.
Mm-hmm.
It's not that you actually have resources URLs, but resources in the image.
Yeah, the image URLs have resources in it. So the main URL you type in is just your normal one. So by dumping it into a separate folder like this, though, they can't look at your code anymore if they guess the URL for it, because they can only find stuff that's in the assets subfolder. And even then, you have to access it through the resources URL, which can be tricky to figure out if you're trying to hack someone's server. More explanations. Oh, more typically, you'll have your prefix be the same as the folder name. Still works the same way. All right. So yeah, here's how the massive list of function calls all kind of match up in their types. You can look at that if you are interested. If not, Just know it all works. Don't ever trust a file from the user. The user sends you a file or something. Don't just trust it blindly. It can be whatever. They could name the file the dot dot slash dot dot slash dot dot, where dot dot is go up a folder. They can go up and then find go to Windows 32 and start sticking stuff in your OS folder, which is not what you want. But don't trust the user blindly. So yeah, the exercise here is to create just a static HTTP server. All it does is serve the entire contents of the current directory. That way you can just put plain HTML pages in there and it will work. There's the answer. Not very big. I mean, that's it for this set of slides.
So if you had the resources and the assets being assets, would you need to still search?
Yes, because it's asking for assets / Toby.jpg. File server, however, is already in the assets folder. So assets folder does not have a sub assets folder. All right, the review's short, and I may not even make it big because it's pretty short. All right, or I may. It's kind of hard to read. It's hard to read for me on my screen. It'll be hard to read for you. Okay. So yeah, headers. You can set it like this: resource.header, response.header. Content type like this is a slice of strings like that. Don't do that. Use the set method. Much easier. Headers have got a lot of different things. You can add if you got a bunch of things that go into the same key. Delete will get rid of header, and then get and set, of course. So get will be typically used on the headers from the request, and set will be used in the response usually. Not sure what write would be for a wire format. I'm not sure. And write subset, again, wire format. Not sure. You shouldn't have to use it. Request URI gives you the path part of the URL. There's a lot of stuff in request. You can find the Godoc and look through it if you want. Lots of stuff. Besides request URI, you can request.url.path, which may or may not be better depending on what you're looking for. I think path strips off the parts after the question mark or the pound sign, whereas request URI doesn't. I'm not sure though. I have to look that up. Anything request.url has got a lot of sub items here. Scheme, user, host, path, query, fragment, lots of stuff to separate out your the URL of the request if you need it. But may or may not be useful. Probably with the Restful, probably is where it can be most useful. So right here he does request URL path, which is that part of it, and the raw query, which gives the query part of it. And then this is a note that when you compile your program, the files like this temp.txt are not going to be served with, are not going to be put into the executable. So that means when you run your executable, it has to be run from the folder that it can get to the files. So like this. So in this case, when you run it, you have to make sure you're in the same folder as temp.txt. If you've got an assets folder, you've got to make sure you run the program from the folder that's got the assets folder. You can't just run it from anywhere. There is a Go bin data program, which will generate Go coded files. It'll basically if you've got a big image file, it'll basically create a variable X or whatever, which is a slice of bytes, and just say slice of byte, and it'll put in the bytes directly. And then you can then And that will then be compiled into the program. You should make your final resulting binary really big, but then you've got the slice of bytes you can do something with it if you need to. Don't recommend this. You probably want your exe to be small and set in assets as a separate files. Also makes it easier to change out assets if you have to rebuild your entire program. Not a big issue with Go since it compiles so fast, but you probably don't want to send out updates of the exe all the time, or app or whatever in your OS. Alright, and that's all for that review section. And that's as far ahead as I looked. I went over templates, though, with you guys last time, so I'm pretty sure I can get through this without having to look ahead. We'll see, though. But I think I'll stop the video here.